As long as I got my suit and tie, I'ma leave it all on the floor tonight. And it got fixed up to the nines. Let me show you a few things.
Hello, as you've probably noticed, I am not Mr. Anderson. My name is Kevin Walberg. I'm an AP Bio student under Ms. Hatch, and I'm going to teach you Plasmid Mapping. So, let's get started. First, we have our circular Plasmid map. It's a little bit harder because it's one full continuous strand of DNA. And then we have our linear Plasmid map, which is easier because it's one strand of DNA, but it doesn't cycle around quite like the circle does. So let's start with the circle, since it's so much harder. And here we have our two different restriction enzymes on Plasmid A. There you go, Plasmid A and the other one, so as not to confuse you guys just yet. And Plasmid A consists of 1,800 base pairs. That's approximately 3,600 nucleotides. I'm not going to get into how many hydrogen bonds, it varies. And the red Plasmid map is Plasmid A being restricted by the restriction enzyme EcoR1. Okay. And the yellow is it being restricted by BAMH1. And both of these restriction enzymes are commonly used in AP Bio questions, so don't be surprised if you do see them again. And since these both cut in the same place, I'm going to go through both of them at the same time. So you almost always draw that first line right there, the connection between the 0th base pair and the 1,800th base pair, or the final base pair in most situations. And there it is again in BAM. And then I'm going to go about a third of the way down because it said 600 base pairs, 600 over there too, and 1,200 down there on the other side. Base pairs up. I forgot my units. I'm going to go ahead and unit those up. Okay, and then 1,200 base pairs down there in the last little section. There you go. And now we're going to show you what it looks like when we combine EcoR1 and BAMH1 on a single plasmid, shown by our nice little orange plasmid map right there, Plasmid A, and it still consists of 1,800 base pairs. Right. And we're looking for certain segment lengths. Our segment lengths for this are 200 base pairs, 400 base pairs, okay, and then 1,000 base pairs. And I know you're thinking that does not add up to 1,800. Well, that's simply because there are two 200 base pairs. Two 200 base pairs. Okay. So now I'm going to make the first cut. I'm going to go BAM colored. So first cut's going to be right there at the origin, like it normally is, and 600 down. So there's 600 and 1,200 on the two respective sides. So now we need to find a place to put eco where it dissects that 600 into a 200 and 400, and still leaves a space to put 1,600, or to put 600 in between, and then 1,000 on the other side. So 200 goes about right there. 200, and then 400 goes about right there. And then if you go about 600 from that other eco, you get about 200 past the yellow. So 200 past the yellow right there. And there's our two segments of 200 and our 400 segment. And then there's our 1,000 segment, base pair segment. And just assume I put base pairs on the other one. I really don't want to take all the time to do that. I kind of figured you'd get the gist of it. And that's how you do circular Plasmid mapping. Next we're going to learn about gel electrophoresis. This is created by putting a positive and negative charge at the end of a gel with plasmid sequences set up at the very top of a ladder. There you go. As you can see, the larger pieces move slower and the smaller pieces move faster. I forgot to label the columns, so I'm labeling that right now. So we got eco, BAM, and both. Both of them are in the right-hand column. That's what you saw in the orange plasmid. Now, as you can see, the gel lines up perfectly with the length of the segments that we found in the past slide. And both lines up with the orange plasmid, again, as we saw in the last slide. The only thing is, as you can see, it does not show the second 200. That's why I normally take my little pencil or whatever I'm using at the time, and I create another one right next to it, as I just did right here. And that kind of reminds me that, yes, there is another plasmid right there next to that plasmid. segment. Also, we have the ladder on the left-hand side. The ladder on the left-hand side kind of shows you how long each segment is, and it's kind of your basis. Okay, now we are doing linear plasmid mapping. So there's two ways you can start, and that's from either end. And I'm actually going to be doing this a little bit backwards, so if you get confused, just watch this in reverse. So I'm going to start off with one cut at 800. Actually, let's make that BAM colored, just because it gives you something to resonate with. BAM colored, there we go. And we're going to go 600 back from that, so about 200 away from 0. That looks like about 200. So that's 600 between the BAMs, and then 100 away from, sorry, not 100, 1,000 away from the 1800. And we're putting an eco at 0 and an eco 600 away, making that first segment 200, second segment 400, and the last segment 200. And I can say that my lines are not even. It doesn't matter too much, just as long as they actually kind of don't look like this, as long as they're more, you can tell the difference between them, like the 400 and the 200 are about the same size. And then that last little segment is 1,000, and if you add them up, 400 plus 200 between the BAMs is a solid 600, plus 1,000 plus 200 is a solid 1,200. Now here's how you draw circular plasmid maps as lines, or linear plasmid maps. Since plasmid A is dissected twice in this case, and it's still 1,800 base pairs, you are going to draw, as you're going to see in a second, one line, which is 600 base pair, and then another one twice as long, which is 1,200 base pair. And for educational purposes, I'm actually going to change that to just one cut, so it's 1,800 base pair, and that's because I'm just showing you that if you cut a circular plasmid once, you get a straight line of the full amount, whereas if you cut a linear, you get two segments of equal amount in this case, because I cut it directly on the 900. Let's see, I'm going to redo the circular. There we go, 1,800 base pair. And I got a little formula here for you. So if it's a linear, then it is one cut equals two segments. Two segments, there we go. And then if it's circular, then this is the only occasion, one cut equals just one segment. It's a very valuable thing to remember. I think it was an AP question not too long ago, so you could get asked about that, and I've honestly had a great time. I hope you have too. I hope you learned quite a bit. If you didn't like this, congratulations. I don't think I'm making another one. If you did like it, well, sorry, I'm not making another one unless there's something in it from I get now. And I had a great time, so stay classy, AP Bio.